kick us off. All right. Good evening, everybody. Welcome. I'm Doug Zemeckis, Marine Extension Agent with Rutgers Cooperative Extension. Tonight, we have a webinar focusing in on coastal hazards and flooding. Two excellent speakers tonight, Dr. James Shope and Amanda Archer. This seminar is number 3 of 6 of our fall seminar series, The Winds of Change, Environmental Impacts from an Altered Climate. This is part of our Earth Day Everyday program, a collaboration between myself and other colleagues and extension agents with Rutgers Cooperative Extension. And with Extension, we bring science-based educational programming out to the communities and stakeholders throughout New Jersey to improve the quality of lives, business, and communities through science-based education. This Earth Day Everyday seminar series covers a variety of environmental-related topics and issues here in New Jersey and beyond. This fall, we're focusing in on climate change-related topics and altered climate observations and science on issues here in New Jersey, covering a mixture of terrestrial and marine topics. Tonight, we're in the marine realm with James and Amanda talking about coastal hazards and flooding. Past recordings from this year, this fall, and the last approximately 3 years of the program, Earth Day Everyday, are available on our website from Earth Day Everyday and visiting links to our YouTube channel for Cooperative Extension New Jersey Agricultural Experiment Station. Some navigational aids for tonight's webinar. We expect approximately 1 hour of a webinar program this evening. As I mentioned, we have 2 speakers. We'll be splitting the time between James and Amanda. And then we'll have questions and answers. We'll hold until the end. I'll be serving as the moderator for the Q&A at the end. If you have questions for either speaker, please put them in the chat feature and send them directly to me, Doug Zemeckis. I'll be organizing them, and we'll get through as many as we can at the end, and also providing you with the speaker's contact information if you'd like to follow with them or any of us with the program afterwards. Next slide, James. Thank you. At the end of tonight's the second speaker during the Q&A period, my colleague Steve Urjo is going to cast live a poll, an evaluation poll and survey. That survey is used to collect your input on your based upon the program tonight, what you learned, and anticipated future behaviors you might take as a result of what you learned tonight. With our institutional review board, IRB at Rutgers, they consider this survey as research, and therefore you as research subjects, we will use the results from your survey responses to help improve the quality of this program and other extension outreach programs. The first question in that survey will be your consent to participate in the survey. Hopefully you do, so we can gain your valuable feedback. If you wish not to, you can click no and further ignore the survey. If you have any questions, you can reach out to any of us from our team, particularly Dr. Amy Rowe, as issues relate to the consent form and the survey. Next slide, please, James. Also, we at Rutgers Cooperative Extension have financial support and partners, many of them, including at the county, state, and federal level, and the U.S. Department of Agriculture. We are an equal opportunity employer and program provider, providing educational programs and science-based information through extension, offering that information through programming such as this, Earth Day Everyday program without discrimination and to as many people as possible, having it here in a webinar-based format so as many people as possible participate live, and we are recording to post a recording afterwards to also provide that educational opportunity to other people who aren't able to join us live this evening. Next slide, please, James. Great. With that, I'd like to thank everybody again for joining and participating this evening for this seminar, and formally introduce our first speaker this evening, Dr. James Shope. He's an assistant extension specialist with the Department of Environmental Sciences here at Rutgers University, specializes in coastal processes and climate change adaptation, hence why we brought him here to speak about these very important topics as a part of this series this fall. He has a bachelor's degree in environmental sciences from Emory University, PhD in earth and planetary sciences from the University of California, Santa Cruz. He worked multiple postdoctoral researcher positions on the West Coast with the Nature Conservancy, University of California, U.S. Geological Survey, working on related issues to climate change, coastal hazards, flooding, and how that impacts coastal communities and ecosystems. He's been here in the New Jersey area for about 5 years now, bringing that expertise to the East Coast, working on climate data and projection analyses and climate change adaptation, mitigation, and resilience strategies. So a real expert with many years of expertise. We're fortunate. Please join me in welcoming James Shope this evening. And I'll turn it over to you, James. Looking forward to your talk.
All right. Thank you very much, Doug. And to everyone, I'm going to apologize in advance. I'm a little under the weather, so if I sound a bit like a frog or I end up coughing, don't worry too much about that. So, as Doug said, I'm an Assistant Extension Specialist in the Environmental Sciences Department here at Rutgers. And also, as Doug said, my background is specifically in coastal hazards and sea level rise hazards. So I'm not going to spend too much time on this, but just to show you my chops on this. My PhD work focused on modeling flooding and erosion hazards along small Pacific islands like Kwajalein Atoll here in the Republic of the Marshall Islands. Or, here's wave-driven flooding at Majuro in the Republic of the Marshall Islands. And so coastal hazards and sea level rise are very close to my heart. My postdoctoral work looked at how we could maybe use coral reefs as coastal hazard risk reduction in terms of flooding. Basically, can you attach a dollar value to a coral reef in terms of being a flood protection structure? And also looking at estimating extreme water levels along the U.S. West Coast for flooding and erosion hazards. So it's a little hard to see where this bacon strip here, but zooming in on it, every 100 meters along the U.S. West Coast, I provided projections of potential for erosion, overwashing, say, a dune, or causing permanent inundation for a location based off of a very large wave event. So again, that's just some background on me and my approach and how I think about these processes. I think about them very much from the physical end and how the water impacts the land, basically. And what I want to do is start out with just a primer on sea level rise, kind of writ large. So how do we know that how do we know global sea levels are rising? Well, if we look back in the geologic record, and I think this is probably going to be only the second most annoying graphic to describe today. We can look at ice cores to get a sense of how temperature and carbon dioxide vary together. So the way you look at this is 0 here is present day, and then as we go to the left, we move back in time to 800,000 years. And so in bubbles in ice cores, we can measure the carbon dioxide concentration of those bubbles that are trapped in there, as well as looking at various proxies for temperature. And what we see is when we correlate those, we see that these lines, the dark blue being carbon dioxide, so a greenhouse gas, and then the light blue line being temperature, they match up pretty well. Not 1-to-1, but pretty good. And when we look at the present day, we see broadly the same trend. So this is showing the change in the change in global temperatures relative to a pre-industrial baseline, basically an average from 1881 to 1910. So that's the light blue, compared to the concentration of carbon dioxide in the atmosphere. That's the green. And again, you see that they're both increasing. And because our carbon dioxide level is increasing at a faster rate, we see our temperature increasing at a faster rate as we go along as well. Basically, as we're pumping more and more carbon dioxide and other greenhouse gases into the atmosphere, our temperature is following suit. And what we've seen is that since about the 1970s, 1980s, so we're looking in this ballpark here on the graphic, that rate of temperature increase has been much stronger and faster than it was, say, in the first half of the 20th century. So things are warming, and broadly, greenhouse gases are to blame. And a direct result of that is increased global sea levels. And I'll get into how that drives it, but just to show you the data at first, this is global sea level. Hang on, I want to move the little zoom bar here. Global sea level, and in this case it's now in millimeters, so it's the change in sea level compared to this 1993 to 2008 average. These two different colors represent two different studies, but basically to determine sea level change, we either look at a conglomeration of all the tide gauges across the world, or in the more recent decades, we look at what's called satellite altimetry. Basically, we can measure the surface distance from a satellite to the ocean itself, and you can do that for a bunch of different satellites, a number of different times, and it gives you a much more accurate measure of your sea level at that point. We've only started doing that since 1993, so that's why we have to rely on tide gauges to go further back. But if we were to look at this full swing here, we're looking at about 0.25 meters, so 250 millimeters of sea level change between about 1880 and 2020. So that doesn't sound like much, but it's really fast as far as these geologic records go. And it's a little bit hard to see from this graphic, but we are seeing an increase in rate as well in more recent decades. It is giving me, there we go. So when I said temperatures, I said temperature is the primary driver of these increased sea levels. So what does that mean? There's two big processes that contribute to global sea level change. The first one's pretty straightforward. It's melting land ice. And broadly, and this is probably fairly intuitive, as the atmosphere warms, as temperatures warm globally, your ice sheets, like say in Antarctica or Greenland, as well as your glaciers, they melt, and that melt water has to go somewhere. So one way or another, it finds its way into the ocean, and so the ocean begins to fill like a bathtub. So you increase sea level from that. But what's historically been a bigger driver is what's called thermal expansion. And thermal expansion is broadly the term used for an increase in the volume of something as you warm it up. So a good example of this is a thermometer. So whether you're looking at a classic mercury thermometer or a modern one that has colored alcohol in the thermometer, when it's cooler, the molecules are close together. And when you heat it up, those molecules begin to bounce around and the volume of that liquid increases. And that's what causes your thermometer level to rise. You could also replicate this, like in a lab, say you wanted to just heat up some water and like measure the difference between one elevation before and after. This makes it look a lot more dramatic than it would actually be, but you could actually measure it with a ruler, so long as you're not actually boiling off the water as you're doing this. So at the global scale, what's happening is the ocean's heating up by several degrees on average, but because there's so much, that expansion in volume, we notice that on the surface as sea level rise. But that's global sea level rise. That's not necessarily what we experience. So this graphic here is showing what's called relative sea level change. And it's showing the number of different tide gauges around the US and the number of inches of change between the years 1960 and 2020. And what you can see is it's not the same everywhere. Different parts of the US are experiencing sea level rise at different rates. The way that I always tell people that I think about this is your absolute sea level rise is what you can just get out and measure from a satellite, and it's pretty consistent. Your relative sea level rise is what you would experience if you were to step out onto the beach in Atlantic City and just hang out there for 50 years. How would that sea level rise experience be for you? And what we find is, in addition to these kind of larger contributors to global sea level rise, you have these really local contributors, changes in circulation patterns, changes in salinity and density. And then at the very local level, changes in your land surface. Basically, is your land rising or falling over time? And in the hot spots that you see here, like the Mid-Atlantic or say the Gulf Coast, those coastal lands are sinking or subsiding over time. And so you have this kind of two-pronged attack, basically, where you have an increase in your global sea level and a decrease in your land elevation, and you combine that together, you have a much higher rate of experienced sea level change. And if you're wondering what's going on in Alaska, same process. It's just in reverse. In Alaska, the land's actually rebounding or rising over time, and that's making the observed or relative sea level change look like sea levels are falling, even though if you were to measure it from satellite, the waters would still actually be rising. So all that to be said, we're in kind of a hot spot in the US for sea level change here in New Jersey, even though it is obscured here in the map. So if we want to kind of put this in context, this is showing change in sea level since 1920 in New Jersey, New York, and for the globe. Or well, it's relative to 1920. That's why you have some ups and downs. And New Jersey here in green, its total amount of sea level rise and its rates roughly about twice the global average. And we're even still a bit higher than New York City itself. Keep in mind, a lot of times New Jersey is proxied by Atlantic City for these things. So, it's not exactly like we're right next to it. So there is some difference here. But sea levels are experienced sea level or relative sea level change is much higher in New Jersey. And that subsidence, that land sinking, is the biggest contributor to that. So I actually have some of the numbers here if you wanted to take a look at them. But proportionally, this blue here represents basically sediment compaction and one type of subsidence, and the green represents a different type of subsidence. And you see they both account for about 70% of the historic sea level change in New Jersey between 1993 and 2017. Now, moving forward, we expect that to change. With climate change, looking at melting from Antarctica or Greenland, we expect this proportion to shift over time. But it doesn't change the fact that this subsidence of our land in coastal New Jersey is extremely important as we think about our hazards and the threats to our coastlines moving forward. All right, so that's been a lot of historical stuff. So what do we think may happen in the future? So this graphic here is from the Intergovernmental Panel on Climate Change, and it's showing global mean sea level change relative to 1900. So very similar to that earlier graphic, this time it's just in meters. The black line is what we saw more or less earlier, showing us about 1/4 of a meter of increase between 1900 and 2020. And moving forward, we don't know how things are going to change. So what we do as scientists is put together scenarios of how things may change. So we essentially assume a certain amount of emissions or non-emissions, a certain amount of warming. So we have this kind of lower scenario suite here saying, okay, if we reduce greenhouse gas emissions and therefore warming, what would happen? All the way up to this really high where we remove all of our stop gaps, all of our, we don't pump the brakes at all on greenhouse gas emissions and warming, and everything in between, and we see where we fall on that. So these are not absolute, they're more like guideposts. And right now we're in between this kind of light red guidepost and this gold guidepost here. So that puts us looking at about 3/4 of a meter of sea level change by 2100 if we continue to follow our current policies. Ignore this dotted line for now. Now, as I mentioned, New Jersey experiences sea level rise at a different rate compared to the rest of the world. So if we were to take a look at that more specifically for, say, a amount of moderate warming, so basically what I was showing you before where we were, and in this case, we're looking at sea level rise relative to the year 2000 by in terms of feet. So the graphic's a little complicated, but the way to think about this is whatever's in the tan area is kind of our likely area of what we may experience by a given year. And then the red is kind of the median estimate or our best guess. So by 2100, our likely range of change is between 2 and 5 feet of sea level rise relative to the year 2000. And our best guess is about 3.3 feet. So conveniently, that's about a meter. Those numbers may seem familiar if you've been following some of the NJ Reel and like state guidance on coastal sea level rise in flood zones that they've released recently, because these are kind of the guiding numbers for those. All right, so what are the effects and hazards of sea level rise? Well, typically people tend to think that the biggest hazard is the encroaching tide. And while that is a problem, it's really not the most imperative one or the imminent one, especially here in New Jersey where we experience coastal storms. One of the bigger problems, kind of long term, but also much more in the short term, is how sea level rise intersects with storm surge flooding. And this graphic explains it really well. So here on the left, we have a house on a hill. During existing high tide, everything's fine. Say a nor'easter rolls in. That nor'easter creates storm surge. And that storm surge just basically stacks right on top of that high tide line. But the house is built to today's specifications. It's protected. With sea level rise, you shift that high tide baseline higher. And then the storm surge comes in, stacks just on top of that higher baseline, and it can now flood inland further, cause more damage. So that, the house is now being impacted. And we've already seen this process here in New Jersey with Hurricane Sandy. So if we were to look at the Hurricane Sandy storm surge extent, that's here in blue, we have had researchers look into it, and they've estimated about 13% of the property damage from Hurricane Sandy can be attributed to human-caused sea level rise. Basically, because sea levels were higher than they would have been otherwise without anthropogenic climate change, Sandy was able to cause about $4 billion more worth of property damage than it would have been able to had sea levels been lower. And keep in mind, this $4 billion is property damage, not health care damage, not economic disruption. It's just one metric, but it's a very telling metric. And if we want to think about how this will change in the future, if you've heard of like the 100-year floodplain, like say you're looking at your FEMA map, that 100-year floodplain basically means a type of flooding that they expect to see with a 1% chance of occurring each year. It used to be 1 in 100 years. That's statistically not quite right. We have been trying to get people within the framework of a 1% chance of it happening each year. But by 2050, we expect that kind of flooding to happen as about 5 times as frequently. And the reason is when you have higher sea levels, you don't need as strong of a storm to generate the same levels of flooding. So we expect to see much more of this storm surge flooding and damage in the future. Now, coming back to the tides, they are important. So this is a picture of what's called tidal flooding. You'll also see it maybe called nuisance flooding or sunny day flooding. And it's literally just when the tides are high enough that they cause flooding inland, absent of any sort of storm or anything. So this is from Ventnor City in Atlantic County. What was it, 2 months ago? Last month? Last month. And you can see that's a low level of flooding. It's not really that crazy, but the problem is it's still impactful. In some cases, it can cut people off from leaving their homes for a little bit, or at least you don't want to get out and about in it, and you can get repeated damage to infrastructure from this type of flooding. So with tidal flooding, the issue really isn't so much the magnitude, it's the frequency. It's how often do you get tidal floods. So this graphic's showing the numbers of days per year that, in this case, it's Atlantic City, experiences a tidal flood. So the orange data cutout down here is just showing the number per year from 1920, in this case, to 2020. And you can see that they increase pretty dramatically, such that towards the most recent few years, we're floating at around 10 days per year. Atlantic City's been experiencing tidal floods. So again, that low level of flooding. Now, if we look at our projections of how sea level may change, these are two NOAA sea level rise scenarios here in light blue and dark blue. They kind of bound our current trajectory. You can see that they increase pretty dramatically. By 2100, basically 3/4 to every day of the year, we would expect to see tidal flooding in Atlantic City. Maybe putting it, back in more near-term type thought process, we're looking at maybe 75 to 175 days by 2050. And that kind of links to the problem with tidal flooding. The question that this kind of raises is how frequently can someone living in a coastal community stand to be flooded like that? again, it's a nuisance. It's not that bad. But how frequently can it flood and you be stuck at home for a few hours? What if you have health issues? Those kind of decisions are slowly starting to come to the fore as people are having to deal with these kind of tidal flooding hazards. And then finally, you can't talk about the New Jersey coast without talking about um, storms or cyclones. So I'm going to talk primarily about tropical cyclones, so basically what turns into hurricanes and what are hurricanes, as opposed to nor'easters. The simple fact of the matter is we don't have a clue how nor'easters are going to change in the future. Well, some people do, but I don't. So when we talk about tropical cyclones, so our hurricanes, we know that warm water and warm humid air fuels more intense hurricanes. So as the world warms, we expect to see more energetic hurricanes, so more categories 1s and 2s versus, sorry, 3s and 4s versus 1s and 2s, as well as expect them to intensify more rapidly. So picture down here is Hurricane Ida before it made landfall in Louisiana in 2021. It encountered a ton of warm water and jumped up in category before it made landfall. And the emergency response between different categories of hurricane are very different. So if it intensifies very rapidly, that can become very problematic for coordinating any sort of on-the-ground response. We saw a similar issue with Hurricane Milton earlier this year as it was steaming across towards Tampa Bay here in Florida. And we virtually expect them all to present more rainfall as well. Now, if we were to look at this graphic over here, this is what's called the Accumulated Cyclone Energy Index. Don't worry about that. This is a proxy for how active each hurricane season is each year. And it's conveniently labeled above normal, near normal, below normal. And what you can see is in more recent decades, we've had more frequent years above normal compared to prior decades. It's not that there wasn't more active than normal years. It's just it's been more frequent in recent decades. Okay, so that's kind of our bigger hazards, but I want to talk about the actual shoreline itself in terms of erosion and shoreline change. And the first thing to keep in mind or to know is coastlines are meant to change. They evolve over time in response to sediment supply, in response to waves, in response to a number of different things. So what this is showing, it's a little technicolor, and I'll admit the scale isn't the best, but showing historic shoreline positions around the Atlantic City, Ocean City area, Brigantine. In this case, the red line is 1830, and then the more cooler line is more recent. In this case, it's 2018. And you can see that, especially at these ends of the barrier islands, they change pretty substantially. And you'll notice that the change is even greater along these non-populated areas compared to, like, say, Atlantic City, or as we go down here towards Margate and the like. So again, I want to establish a baseline. Barrier Islands and the coast of New Jersey change. Now, there's two big processes that drive that change. One is coastal erosion by waves. So if you put sand on the beach, the sand doesn't just stay there. It either moves offshore, onshore, or it moves upshore or downshore. And what causes it to move upshore or downshore is wave action. So basically, if a wave is coming in towards the shoreline, it's typically coming in at an angle such that it'll push the sand up one way and then drag it back down. You have this sawtooth pattern. And what you end up with is a net movement of sand. In this case, it's sand downstream, but I always say down coast, basically following the current that's along shore. And then that process is enhanced when you have more wave energy. So when we think about what causes more wave energy at the shoreline, basically a wave's more ability to move sand or cause flooding, that's dictated by sea level in a very real way. So this graphic here is showing, how much extent of run-up you would get of a wave on shore as sea levels rise. And you just see that the run-up would increase with future sea level. And what this means is that more wave energy reaches the shore, and that means that there's more potential for erosion as sea levels rise. So a simple way of thinking about this is if you think about, say, a nor'easter and then like the wave action on top of a nor'easter, you're already getting that elevation due to the storm surge. You can get a significant amount of erosion. For example, here's dune erosion in Bay Head following a nor'easter in 2021. You can see it's just cut right into it. And primarily this kind of erosion is going to be due to uprush onto the beach and rushing back out, taking sand away with it. From wave action, from surging action, and the like. The other kind of erosion you're going to get on the beach is what's called overwash. So this is in New Jersey, this is in Florida, but it's a really good photo, so that's why I wanted to include it. Showing the before and after aftermath of Hurricane Michael. So you don't necessarily always have just down the shore. You can also have erosion where sand's thrown onshore or taken away from it. And so if you look at this before and after, you can see these kind of, well, one, you can see this entire breakthrough here, but you can see how the sand is swooping in towards the bay here, where there's been a significant amount of overwash, and you can see sand's been thrown up onto the dunes here. So we know the shoreline changes. We know waves and overwash action can cause coastal erosion, and that can cause, damage and the like. So what do people do to deal? So one of the first things that you see in the literature and you see in action, and historically has been most popular, is coastal armoring. And this is the process of putting in some sort of hard structure that will either retain sand or keep erosion from happening in one way or another. So for example, here's Cape May. There's a number of groins that are built here. Those are these kind of perpendicular to shoreline rock structures, and they're meant to trap sand. And you see they do a good job of it. So because I'm a coastal scientist, I can tell you that the flow of sand and the flow of water broadly due to wave action is from the north to the south here in this because of the way this is shaped. The issue with a groin is once you put one in, you're collecting sand and that sand's not making its way downstream. So if you're in this case, it's Cape May, so there's not much downstream. But you can imagine if you were further south from here, your input of sand to your beach may be being blocked. And this is a problem that we see everywhere. Basically, once you build a groin along one part of the coast, you end up having to build more of them to keep your beach from eroding further downstream. You can also build seawalls or put in riprap. That's the rock structure here in front. This is Cape May in 2010, so it's an older photo. And in this case, you're putting in a hard structure to help prevent erosion and in many cases with a seawall, preventing flooding. The downside is you basically almost all the time, unless you do it just right, if you put in seawall or any sort of hard structure, you'll lose your beach in front of that. Basically what happens is a wave comes in shore, hits the seawall, bounces off about as hard as it comes in, and it takes the sand with it. That's a process we call reflection, but you don't get like the kind of natural motion that lets sand be deposited on the beach. You just make sure it's carried out away with the wave. So we've gotten better about this in recent years, kind of as a nation, and making sure that we're putting seawalls in smartly, but they can still be problematic if you're trying to use it to preserve your beach, because most of the time they won't. And one thing that people also do is beach nourishment, and this is huge in New Jersey. So here on the left is this is a Sea Isle city. This is in April earlier this year of an active beach nourishment project. Basically, beach nourishment is where you take sand from one location, maybe you dredge it offshore, maybe you source it from a bay, maybe you bring it in. I've seen it trucked in where the sand is mined from on land, like a nice, pure, ecologically sound, I guess, location, and it's trucked in and then pumped out onto a beach. And typically you do this for 3 reasons. 1, you do it to build your beach wider. 2, you do it to build a dune to help protect protect the structures behind that dune. And you do it to basically, make your beach nicer for tourism. And I mentioned that last piece because it's really important here in New Jersey. Beach tourism is a huge economic engine in New Jersey. Now, if we want to put some numbers to it, about $3 billion have been spent on putting sand on New Jersey beaches since 1936, and that's adjusted to 2022 dollars, I believe, is where I got that from. And if you were to look at the total beach nourishment by state in terms of the number of cubic yards of sand put out on the beach, New Jersey's number 3 after California and Florida. We have a much smaller shoreline than both of these places. So it's an interesting statistic. And then New York is pretty much all Long Island in terms of that. So anyway, oops, I lost my thing. Yep. So one of the things that I'll get into it in a little bit about beach nourishment because it's a hot topic. Okay. And then the last thing that people do that people have talked about but haven't done a ton of is what's called managed retreat. And this is a dirty phrase on the New Jersey coast. So I'm not gonna, I don't have a horse in that race, but the idea is progressively you move people and homes out of the way to allow the ocean to just kind of do its thing. Sea levels are going to rise, it's going to cause more flooding and erosion. So over time, you're just kind of backing people away from the coast. So some of the downsides of that is it's costly in the short term. You can imagine uprooting people and the like, that's a lot. It can disrupt your local economy, especially if you're tourism focused on the beach. And it can also disrupt local culture. It sounds weird to say culture as if it's different from one part of New Jersey to another, but it really is. And your beach communities they have a culture built around them. And, a lot of folks would be sad to see that go if you were to move these communities. But that being said, this is a more viable long-term approach than armoring or nourishment. The problem with nourishment is as sea levels rise and you get more of that energy available to erode the beach, you're putting more sand on the beach and it's just going away a lot more rapidly. So today it may make financial sense, but maybe in 10, 15 years as sea levels are higher, it may not make as much financial sense or it may not even be doable. And financially or economically to be putting sand on the beach. So one of the things that I'm interested in as a researcher is thinking about that tipping point. At what point does beach nourishment not become economically viable, even if it is supporting tourism and the like? At that point, that's when we have to start asking ourselves some hard questions, and I don't know if I'm ready to do that yet. Yep. So with that, I think I'm going to wrap up. Again, happy to get into the more hot button issues out there at the end, but I just wanted to kind of wrap all around just so you get a full sense of sea level rise, coastal erosion hazards, and just kind of flooding hazards that we can experience here in New Jersey. And if you have any questions or want to follow up, here's my email, and also Doug will have that as well.
Awesome. Thank you very much, James. Very interesting, effective, and great delivery to help make us understand the science better behind sea level rise and coastal hazards in different areas, but including here in New Jersey. We did, and it very well timed too for the evening to keep us on a good pace. I did throw your profile link in the chat so folks can capture your contact info from the screen from that link or when they get the recording afterwards.
Awesome.
But yes, thanks, and please stand by. We have a second speaker, but then we'll go through Q&A shortly. Next up, for about a 15-minute presentation or so, we have Amanda Archer. Amanda, thank you for joining us while you're on the road for a related conference up in Maine. Amanda is the coordinator of the Coastal Training Program, which is under the J.C. NEAR, the Jacques Cousteau National Estuarine Research Reserve. part of a national reserve of estuarine research reserves throughout the U.S., partnership between Rutgers University and NOAA. Amanda's been in this role for about 2 years now, and in this role, she provides up-to-date scientific information, access to technological and skill-building opportunities to professionals who are responsible for making decisions about coastal resources. She also works in citizen science and outreach related to coastal processes, erosion, and sea level rise. We work together on related issues and how they impact our commercial fishing industry here in New Jersey a few years ago, producing a resilience checklist to help the commercial fishing industry better prepare for these hazards and changes. And she's, I can tell, attempting to get her slides queued up, and I hope there it looks like they are. Great. And tonight, Amanda's joining us. She's going to focus on presenting about the MyCoast, New Jersey project, where they're working with citizen scientists and other researchers to help document our changing coast. Amanda, thank you very much for joining us. I'll pass it over to you.
Thanks, Doug. Hi, everyone. My name is Amanda Archer. I work for the Jacques Cousteau National Estuarine Research Reserve. I'm going to talk about MyCoast, New Jersey, and what you can do in your communities to help coastal scientists document coastal change. And so to kick us off, the Jacques Cousteau National Estuarine Research Reserve is located in Tuckerton, New Jersey. That's where our headquarters are. You can find us on Great Bay Boulevard, out right before the Rutgers Marine Field Station. And we are partially funded by NOAA Office for Coastal Management, and also our partner agency is Rutgers. And so with that, we are one of 30 reserves throughout the nation who do education outreach and research in our estuaries systems. And so the Mullica River Great Bay estuary system is actually one of the most pristine estuaries on the East Coast because of the protection of the pine barrens in its headwaters. And so we take a lot of pride in being able to give programming around this awesome place. And so we have a research sector, we have an education sector, we have stewardship, and I do the coastal training program, which essentially helps deliver science to decision makers about making the best decisions for our coast, given all of these pressing issues that we're experiencing with all these coastal hazards and flooding. And so that's just to give a little bit of background on what the JC NEAR is. And if you're ever in the area, please stop by. We have a public trail that goes out to one of our grassland marshes, which you can see out here in the background of this photo. So to kick us off, as James had teed up for us, is that coastal New Jersey is so much more than the shore. The area in the dark blue represents all of the tidal waters around the state of New Jersey, and the area in light blue represents all of the municipalities that are touched by tidal waters. So in New Jersey, we have over 500 municipalities that are governing their land use differently. And so it's really important, my role, to help educate them on our changing sea levels due to like how many municipalities are touched by these tidal waters and going to be affected by the sea level change. And so one of the tools that we love to use is called MyCoast, New Jersey. And this is a portal that's used to collect and analyze photos of coastal events and places. If you're interested, you can scan the QR code. We do have an app version that is available for use. You can create an account. And these photos are linked to data about weather and tides, and it helps create reports that help stakeholders and decision makers, like government agencies, business owners, and residents, understand the coastal change that is happening on the ground and help make them informed decisions. So this is just the home page. We have a web page version and an app version. So I will have this QR code up at the end for anyone who does not get it right now. So just to go into MyCoast a little bit, we have a couple of different tools that are available for use. The first one being high water, which helps us track flooding across the state. The Second one is called Places We Love, and this is an opportunity for users to document the coastal places that mean something to them and that they love and want to protect. We just launched a brand new tool called Photo Stations, and I'll go into more of that, but that involves community shoreline monitoring. And then we have 2 general campaigns on MyCoast. The first one is Know Your Tides. I'll go into this a little bit more throughout the presentation, but it helps monitor local tides, gives you easy access to do that. And then Rising Together New Jersey is an outlet for people to share flood stories, connect, and just, have a place to really reflect on the changes that are happening and talk to other people who may be experiencing the same things. So diving into the first tool, this is an example of our high water report on MyCoast. And so users would essentially go out and snap a photo of high water in their community. In this case, this photo was taken in Atlantic City in 2023, and you can see a car going through some floodwaters. When this photo is uploaded, it is automatically linked to title and data and weather information. So at that time the photo was taken, it links to the nearest tide gauge. So in this case, the tide gauge is from Atlantic City in the ocean. I believe it's a NOAA tide gauge. It gives you the water level at the time of the report, so 5.7 feet. And then it also gives you a nice little graph spit out of what the predicted water level was versus what was actually observed. So this blue line here shows the predicted water level, and then the red line shows the actual observed water levels at that tide gauge during when the picture was taken at this yellow dot. So in this case, the photo was taken on a falling tide. It also gives us the weather overview, which way the wind is blowing. The wind speed and direction affects how coastal communities flood, whether it's back bay flooding or not. Sometimes water gets trapped in the back bays and just continually rises. It gives us temperature, and it also gives us the rainfall. So it gives us the rainfall in the past 24 hours to see if this was a case of sunny day flooding or if this was storm related. Scientists can go back and look at these photos to kind of figure out the clues as to why we're seeing this flooding. And then it also links to a riverine tide gauge. So the closest one in this case is Absecon Creek. So for more inland communities, this can be used as well, and it will connect to the nearest riverine tide gauge. So it has the location of the photo. And the really awesome thing about this high water tool is if you were to click on View on New Jersey Flood Mapper, this yellow button, it brings you to one of our Rutgers tools called New Jersey Flood Mapper. And not to get too far into it, this is a tool that is used for city planners. But if you would like to play around with maps and see it for yourself, you can adjust water levels based on the mean high water, which is the highest high tide line. So in this case, MyCoast is linked to New Jersey Flood Mapper, and we see the location of the photo here with the photo present. And so what I did was I played around with New Jersey Flood Mapper, and I tried to match up the scenario that we're seeing on the ground with a New Jersey Flood Mapper scenario. And so in this case, you can see a little bit of flooding outside of this building, which is about 2 foot of inundation in a low-lying area during this. And so this just gives you the ability to really ground truth some photos, and helps researchers kind of make their models more detailed based on what we're seeing on the ground. And so I'm going to hit next. And what we see here in this map, the photo location is right here. And this would be an example of what Atlantic City would look like with 3 foot inundation in low-lying areas. And so another fun thing with New Jersey Flood Mapper is that it has the ability to show where critical assets are. And so using this tool, I was able to find out that this picture was actually taken at a school. So So it just got me thinking about, okay, how many days is this area flooded, and can it prevent kids from getting to school? And that's something that planners can look at and help determine and use all of these tools to plan for the future. You can also submit past reports on New Jersey, on MyCoast New Jersey. You can submit any photo from a past flooding event. The time and location will be automatically linked upon submission. However, if the photo was taken prior to all of the location services that were embedded in like the new smartphones, it's important to review when and where the photo was taken to ensure an accurate report, because it's going to ask you to manually put in location, time, and date. And it will go back into records of title data and find that title data and weather data and link it to that report as well. So we encourage submissions of past flooding so we can compare them to recent reports. Places we love, it's very similar to High Water Tool. However, it's not flood eccentric. You can snap a photo of anywhere you like in the state. Places you love, you can tag it with different tags of history, culture, tell us why you love it. And it just is a place for people to highlight all the really awesome places in New Jersey that people love and want to protect. Know your tides. So if you download the MyCoast app, it will link you make an account, it will link you to your location. Make sure you have location services on, and it will link to your nearest tide gauge and keep you up to date on upcoming tides for your area. The same way as we saw in a high water report. So you can get alerts sent to your phone about tides. We also send out high water alerts when there's potential storms or predicted flooding happening. We are seeing this happen a lot more often, especially sunny day flooding. So when there's a new or full moon is usually when we get those higher than normal tides. And that happens about once a month right now. And just we have these little graphics to give information on all of that. And as James had shown us in a couple of his graphs, we are expected to see more sunny day flooding into the future. And by 2050, it could reach 120 days a year. So when I think back at that flood mapper photo of the school that's continuously inundated, imagine 120 days out of the year, people aren't able to get to school. And so that's really going to change how that community functions, and we need to plan for those changes. When will tides be higher? So we give a couple of predictive dates on the website. We just had a past flooding event, October 15th to the 21st. We can expect our next predicted flood event, not saying that there won't be one in between, because we can always expect that there might be something else. But with the full and new moons, we can see our next high tide flood event is going to be November 14th through the 18th. And we also host some pretty cool contests about king tides, where you can win prizes for submitting flooding photos during contest dates. Rising Together New Jersey, just another outlet for flood stories to be shared. Some stories are about small changes over time, and others could be about life-changing events. This is just a platform for people to share their experiences and give a little bit more of a narrative and a story behind their flooding experience. And it's really awesome to read some of those stories and be able to use it in some of our education and outreach at the JC Near. All right, so brand new as of September 2023, we installed 6 photo stations along the New Jersey coast. Most of them are in state parks on various coastlines, and it helps us document changes to our coastlines, like similar to what James was showing us on the aerial shot of those changing coastlines. And so it gives us on the website a time lapse of photos collected over time to see that change, which is a really neat tool to use. So these are where they are currently located. We have one in Liberty State Park, one at Cheesequake, We have 2 at Island Beach State Park, one on the ocean side, one on the bay side, one at the Margate City Pier, and one in Cape May Point State Park. And so here's an example of like still shots of some of the time series that we've gotten so far. So in February 2023, when we were siting photo stations, I snapped a photo of this dune at Island Beach State Park. And then when we were finally ready for install, we got our first report, and this is what it looked like 6 months later. So after the vegetation has grown, you can see that the winds really beefed up that dune naturally on that shoreline. And then we have Margate City Pier. This first picture depicts a low tide. And then the second picture depicts a storm surge / flood tide. And then at Cheesequake State Park, this is more of a natural back bay feature in the marshes of Cheesequake. And it shows what the marsh looks like at low tide. And then during a flood tide, the changes to the creek. And so right now we are actually doing a photo station challenge. It's a little bit late. We close on October 31st. But if you're interested in getting out over the weekend and doing a little road trip, this is very similar to the Lighthouse Challenge, which is either this weekend or just happened. But you can hit these too while you do that. And so if you submit a report at each of these photo stations by October 31st, you will be able to claim a prize for participating. And you can follow one or more of these social media accounts to stay up to date on all the contests that we share through MyCoast. And so why does all of this matter? So MyCoast essentially helps researchers and educators talk about the science and actually dive into some of the data. So folks go out and take photos where we can't be, where people might live. We can't be everywhere at once, and it gives us an opportunity to crowdsource all of this data. And so this visual science and storytelling then informs decision makers in your town, and helps makes informed management decisions. So I'll go into what that means a little bit more. And then we also use your reports in this education and outreach, like I had mentioned. And so it's just this nice little framework that kind of helps this whole initiative deal with coastal hazards and flooding. And so how do people make informed decisions off of your reports? We have this publicly available for your municipal leaders or people who make decisions in your town to go in and download these reports with all of the data, and they can be used in applications for whether it's infrastructure funding or something that helps the resilience in your town. These are the data. This is the information that can back those grant applications that could potentially help your town with funding for coastal resilience. And so there's other ways that you can use MyCoast data and photos. And so real-time awareness is one. If someone's moving into the area and they want to see how often a place floods, they can check out MyCoast for real-time flood events. It can be used in planning, like I had mentioned with Flood Mapper. Practitioners can use it for project siting and design. Some people can use it in their permit review. So if New Jersey Department of Environmental Protection is reviewing a grant application or something along those lines, they can look to MyCoast to help approve permits based on what they're seeing the community is posting. Like I had mentioned, grant proposals, it's just some extra form of data that can be included and help beef up grant proposals to help get them awarded for certain issues that they're seeing in their town. And then it also helps researchers calibrate these models and ground truth the data that the models are telling them. And so one example of that we have right now is in the Little Egg Inlet area. And for anybody who's not familiar, this is the southern tip of Holgate off of Long Beach Island in southern New Jersey. And Stockton University Coastal Research Center is doing a sediment transport study of the inlet. And so they're asking community scientists to help snap photos of whether they're out on a boat, whether they're out surfing, whether they're out on their deck, of all the changes to the inlet, whether it's shoaling, erosion, shoreline snapshots. And that's going to help inform the model that they're going to produce for this inlet on how sediment is being transported in and out of the inlet. So that's one really cool project that you can personally contribute to the research for. So what's to come? We want to use this platform to go beyond just coastal flooding, which it already has in some of the community shoreline reporting that we introduced last year. We're going to work with partners to install more photo stations to document shoreline changes. And so with the photo station challenge that's open till October 31st, we are also open to nominations for future photo stations. So if you have a coastal area that you think would be a really good place to put a photo station to help document this change, you can scan that QR code and nominate a site, and then we'll review all of our nominations and pick some final ones for our next round. We also want to use community reports to document changes to habitat restoration sites. So we're going to look into doing some sort of community science habitat restoration tracker to help researchers monitor the restoration sites of coastal areas and nature-based features. And then we're also engaging educators to use MyCoast New Jersey in the classroom as a local on-the-ground climate change education tool. We know that New Jersey has new climate standards in education, and this is a really awesome applied science way to show kids on the ground in classrooms how things are changing in our communities through MyCoast. And so you want to take part, but what you can do, you're already on this webinar, so you're already making these steps to inform yourself about coastal hazards and flooding. So you're already doing something. You can download the app and sign up for high water alerts. We encourage you to post photos and stories to MyCoast, share on social media, attend community events and become an amplifier. Let your town know that this exists, that they can use it to their advantage for coastal resilience. And then also just keep using MyCoast New Jersey, because we can't do it without you. And that is the end of my presentation. I have my contact information at the bottom, and I promised a QR code for the app at the end. So thank you.
Awesome. Thank you, Amanda. Really great job of your talk and impressive work that you and your colleagues are doing, everything related to MyCoast. I've seen the webpage before, but did not realize the reach of the capabilities and the new features in the app and the contest. So well timed that we got you in here just before the end of the challenge as well. And thank you also to James. Really great 1-2 duo there this evening, talking about a lot of the science behind climate change, sea level rise, the implications, particularly out on the ocean front here in New Jersey, and then what the boots on the ground are doing, Amanda and partners, including how people can get involved through citizen science and contribute to this and use the products. So really awesome. Thank you both for contributing your knowledge. As you can see, that popped up. Thank you, Steve, for throwing making the poll go live to get folks feedback on tonight, the teaching and what they learned, how they'll hopefully use what they learned this evening as well. I'll kick us off here for the Q&A panel, moderated for James and Amanda. If people have more questions, we'll be able to handle some more than that already came in and engage in some conversation, hopefully here in the virtual format. But first up, James, Lynn asked earlier on in the evening, is the subsidence that you mentioned because we have a large continental shelf? Does that play a role at all?
A bit. So one of the processes that causes that subsidence is sediment compaction over time. And so when you have a wide coastal continental shelf, you tend to have a shoreline that is what we call depositional. Basically, it's got a lot of sediment. So in a lot of locations, you can get that compaction that sinks over time. Not to get too technical, but the biggest process that contributes to it is literally adjustment of the crust of the earth, frankly, due to the effects of the last ice age. It just takes a long time for that stuff to reshift back to the way it was.
Yeah, I think so. The last ice age or last glacial maximum, it went like right across Long Island, central New Jersey. So South Jersey was actually bumped up and is now recovering.
Yep. Basically, you had all the glaciers pushing down. It caused a bulge right in front of it. That bulge is a good chunk of coastal New Jersey. And so glaciers are gone, so that land's rebounding, and our coastline's sinking back again.
Interesting. Cool stuff. Robert was wondering if heat causes thermal expansion, why does ice have greater volume than water?
That's a good one. Okay, so ice has a greater volume because when it crystallizes its structure, and first off, I'm not a chemist, but its crystalline structure is in such a way that the molecules are spaced out a little bit further. So it has a small increase in volume. Now, that's due to the change from a liquid to a solid. If you just kept it as a liquid the entire time, as you warm that liquid, it would expand. So your 33-degree water is going to have less volume than your 80-degree water, basically. But things get a little thrown out the window when it comes to forming ice. And interestingly, ice is one of the few things where the solid form does that. You say you have like a metal, you have a liquid metal and that cools into a solid metal, its volume contracts. So it's an interesting thing.
You did fantastically in answering that from my perspective. I was trying to recall knowledge from like past oceanography classes, and that stumped me. You got it. Thank you, James. Actually, I'll ask you. I had a question. Earlier on, you had a table and a figure about, and you talk about thermal expansion. But on the figure, you talked a lot about land ice and sea ice and compaction. But where does thermal expansion contribute in terms of the sea level contributing to the sea level rise that we experience locally?
Yeah, so did I not have that? Oops. I don't think I put it in the figure. So where is it? All right, so I'm going to have to just kind of throw this out there because I realized I forgot to put that in the actual little chart, or not the chart, the little bar graph figure, but I have it in the table. Actually, let me just show you, if you don't mind, just so you know, you can see that I'm not just claiming things. So this is it here, global mean thermal expansion. So during this time, this is in terms of millimeters per decade. Don't worry too much about that, but if you look at it, it's about the same magnitude, a little bit less than what we get from that isostatic adjustment, basically that glacial effect and other natural sediment compaction. So it should be roughly the same size of this, so this should be split. So I do apologize. Thank you for pointing that out, though.
Sorry, but I caught a mistake there, but I was also helping me understand, because about the national average around the world, a lot of it's from thermal expansion, but what sets us apart here in New Jersey is that subsidence that puts us about twice the average, right?
Right. So it's really the subsidence, like there's effectively like little bit differences. Like, for example, the water, this is going to sound crazy, but the water from the Greenland ice sheet, it preferentially goes to certain parts of the world when it melts. And one of those places isn't necessarily New Jersey. So don't ask me about the physics of that because I don't know it very well. But when it comes to like where are bigger things, like it's really that subsidence, and then we're getting that thermal expansion as well here on the coast. Okay, I'll stop sharing so people can see people.
Good. I'll have a couple from Amanda, but I'll hold those and I'll cast a few more at you, James, and then we'll jump
Okay.
over to Amanda. But James, Jody asked, are there data on average for how long sand remains with the beach nourishment projects before they are eroded away again?
Depends on the location. I know that's it sounds like a cop-out answer, but it really depends on how much storm activity that location tends to get. For example, you could have a beach nourishment project last 5 years, or you could have it last literally a year, depending on how active your storm cycle is in a location. So I'm sure that there must be an average. If I'm being honest, I don't think that average is going to be super helpful if you're trying to determine how it would impact, say, your community. If you're like living on the coast and like looking at a nourishment project, you would need to look at it a little bit more specifically, like how frequently you get hit by storms, how frequently you get big waves, that kind of thing. Yeah.
Thank you. Two more for you, James. One, you spoke a lot about focusing on flooding on the ocean side. Amanda, some of your graphics, and Amanda talked a little bit about on the bay side. Can you talk about, like, from recent storms in New Jersey, the magnitude of frequency of flooding that you see out on the oceanfront versus out in the back bays?
Yeah. So I'm going to speak to it more generally than just recent ones. So basically, your flooding in your back bays is going to be primarily driven by storm surge. Now, we're on the we're on the east coast of the US. Most of our flooding from coastal storms is going to be driven by storm surge. You get out west, you get in a few other locations, you get more wave-driven flooding. So it's going to be a little bit different. But with that storm surge flooding, you're basically filling up the bays and you're getting flooding coming in from the back. Now, there's a pro and con there. You're not going to get also the combination of the flooding plus big waves, because you don't get big waves in the bays. But you also have a coastline and infrastructure that's not necessarily expecting flooding from that direction, right? You don't have dunes built in that direction that can help protect you. So they can be, well, I wouldn't say they can be. Often they are more destructive in that sense. So it's a really big issue. And from a science perspective, if you're getting into the physics and the math and that kind of stuff, it actually becomes a lot more complicated once you get into the bay than when you're outside of it.
And some different response engineering or others that you might take
Yep.
in the bay.
Yeah, there's if you look at like a lot of the response along the open coast, let's say you're taking like a natural or a nature type solution, all along the coast, maybe the response is to build a dune or something like that. But the back bay is not a natural place to find a dune, so you need a different suite of engineering options. Maybe you're building out a salt marsh if you're sticking with that natural perspective.
Great, thank you, James. I got one more for you. Test the expansiveness and breadth of your knowledge. Lynn is curious, and I know others in our office, including, have talked about this a little bit this week, but headlines were made about AMOC, Atlantic Meridional Overturning Current.
Yep.
I know you're also not an oceanographer, but you might keep up with this if you have any expertise. Are you familiar with what the latest letter scientists wrote with regards to shifting in currents, and will that impact local sea level rise?
So it's going to be a little complicated how it impacts sea level rise. So the AMOC, Atlantic Meridional Overturning Circulation, is broadly your transportation from south to north, and then that water in the north sinks, basically. That process is slowing down, and as the ocean warms, because it really depends on this difference in temperature between temperature and density between north and south. that, as I said, that process is slowing, and there have been folks, and I'm not 100% up on this, that think that that can completely just kind of disintegrate that particular current and that circulation. So that can cause a number of issues, including, more warm water off the coast of New Jersey, which is problematic for us in terms of heat. In terms of how that would impact local sea levels, I'm not 100% certain, if I'm being honest.
Thank you, James, for what you were able to share on that. And Lynn, we might have an oceanographer as one of our next speakers in December or January, talk about the unusual oceanographic conditions we observed off the coast this year. So they might also be able to speak more on that in the future night. When you look it up about whether or not the Gulf Stream's weakening or strengthening, there's actually a recently published paper that questions whether or not it's weakening, like they published a year or two ago. So I think it's still the cutting edge of research and academic debate and discussion right now.
Oh yeah. To follow up with that, it's a very big question mark right now, to a large degree. But that being said, if you get an oceanographer on, listen to them, not me, on that one.
Yes. Good. So Amanda, thanks for your great talk on some of the way people can get involved and the features of MyCoast. What are some of the most, one, or if you have two examples, the most interesting ways you've seen things like flood map or MyCoast data being used in municipal planning and local decision making?
Yeah, so I can say that from my experience so far, the ability for municipalities to go on and download those photos and datas and to include it in potential grant applications for infrastructure. So I wasn't really able to get into too much detail, but like for our Back Bay coastal communities, we're seeing a lot um, of that water being pushed up the storm drains and coming up on more inland areas of coastal communities through the storm drains. And so, what are ways that we can use some of this data to help with grant applications for potential infrastructure improvements in the future? And that's one way that municipalities can use this. It can also be used for if you're looking to armor your shoreline, like with nature-based features or a mix of green and gray infrastructure, you can use some of these photos to show that change over time and kind of indicate it as a priority spot for your community to kind of hone in on. And so those are some ways that I see municipalities using it locally. So yeah.
Great example. And the last question, kind of combined to that, and my question posed to James about the Back Bay versus the ocean front and local decision making, but a lot of folks participating from Ocean County and Barnegat Bay, Reclaim the Bay. We've talked about in the past, like the Back Bay Islands Initiative. Is MyCoast being used to help protect and manage a lot of the back bays that we have in our coastal estuaries, where you see living shorelines and other initiatives ongoing?
I would say not, there's not a direct overlap. Are you talking about the New Jersey Bay Islands Initiative or?
Yeah, the Bay
Okay,
Islands
just wanted to
Initiative.
make sure, because there is a Back Bay study going on, I think with, I don't know if that's Army Corps, so that's something different. But the Bay Islands Initiative actually has their own resource called the Bay Islands Restoration Planner. And so what we're looking to do in the future with MyCoast is do that habitat restoration tracker tool that could be an overlap with the New Jersey Bay Islands Initiative with some of their habitat restoration on those Bay Islands and living shoreline efforts.
Cool. Good to know the connection. Seeing you present on the work and it going to contribute some things that we've covered and in the past and that people are familiar with. Wonderful. Thank you both, James and Amanda, for your time and contributing your knowledge tonight. A real excellent evening and contribution to this seminar series for the fall. Thanks for those who filled out the poll. Appreciate your feedback to help improve this and other programs. Thanks for staying a little late here over originally scheduled time, but I guess I have a tendency to do that. I can't get enough and appreciate the great information this evening. But our next seminar in this series is next Wednesday, October 30th. Jean Epiphan, who's part of our Earth Day Everyday team, she'll be the featured speaker, talking about trees of the living dead in Halloween week theme, how to remove aggressively sprouting invasive trees. So tune in next Wednesday night to hear more. The recording for tonight will be posted shortly and disseminated throughout. So take a look if you want to catch up again or share it with a friend of all the great stuff you learned tonight. Thanks again to James, Amanda, Earth Day Everyday team, and everybody who's still joining tonight or catches the recording later. We appreciate your participation and interest, and see you again soon at the next ones.
Thank you.